3. Good morning, everybody. This is the last session of Cohort 1. We are almost ready. We're going to start in a few minutes. We have one of our admins from TBR, Michael, is here. Our master instructor is here, Eric Woldrich. Our project evaluator is here. Some of the student assistants are here. Before Eric starts, I think he's busy with getting few things. Michael and George, you want to mention a few things? Michael, we are ready almost cohort 2. Today is the day that we are finishing cohort 1. Lectures and follow-ups are almost over, and all 5 colleges got their machines and equipments. Anything you want to say? And also George, before Eric starts, just to warm up.
Yeah, just quickly, I'm excited that everyone's participating in this first cohort. I'm glad that you're able to share your pictures with the group, and then looking forward to what entails as students start coming back in person on the regular, hopefully, and then how you're utilizing that moving forward. So this is exciting. I appreciate you guys giving some time up to do something that's going to be great for your students. So thank you.
And on that note of what to do, so we just dropped your final, well, I'll tell you it this way. We've got your final crucial component on there, lesson 5, dropped today. But what we also have is I will probably add one more that's not as crucial, but it's a little bit more on the advanced side. So for example, if you want to take your fusion skills to sort of that next level, the smoothing, the surfacing, all the real, for lack of a better term, the sexy design kind of stuff, that will follow this, although not as required as, the main stuff. This particular lesson, lesson 6, or lesson 5, excuse me, is about slicing and where to get free stuff, because we love free stuff. And if you don't have to design it yourself, that's the best kind right there. So we introduced the online STL repositories, your Thingiverses, your My Mini Factories, your STL finders, and they keep getting added on. These are free, they're easy to do, and they keep you from having to design it yourself. They also have an incredible benefit of innovative inspiration. You will be amazed at the number of things people come up with and have shared with the world in terms of their designs. And that's the best part. It's open source. So if you see a really useful tool or really impressive design, you just go grab it and you just download and you bring it and your printer makes it. So you don't have to spend the hours and the mentality of measuring and those kind of things to get it done. What's even cooler, so previously you learned on Mesh Mixer and how you can manipulate those STL files. You can merge them together. You can do these kind of things. You can actually go to Thingiverse, download someone else's STL, create some feature of your own, and put them together. So there's a way to merge tools and components. We actually demonstrate this a couple of times in class, where we've had students that have gone and found like a special nut driver that they need, but it was designed for a certain type of, we'll say, screwdriver, but they wanted the nut driver shorter. They didn't want it so long. So what we did was we took the STL of the nut driver off of Thingiverse, sliced off what we needed, went and got a different model of a short stumpy handle, merged them together, brand new tool to print. And that is the power of both the Mesh Mixer and these online repositories. So lesson 5 is going to be dealing with everything that you can utilize and don't have to create yourself. And lesson 4 is the Mesh Mixer that can allow you to manipulate all that. And the last part of lesson 5 is the slicing, the unsung hero of successful FDM additive manufacturing. You can take a pretty low-cost printer, and if you have a good slicer and if you have good knowledge of slicing, you'll turn it into a fantastic machine. The quality of a product is oftentimes controlled by the slicer more so than it is the printer itself. Assuming the printer runs and levels, you can actually take a really good slicer and turn it into beautiful, beautiful parts. So in this lesson, we demonstrate the slicing technology with the Cura software. However, it's free. It's great for you to use with students. Everyone can use it, and it works with just about all the printers out there. However, there is also one that we recommend that is in what we consider the low cost market, and that is Simplify 3D, which looks visually different, but settings wise, they're all still there. So if you're really wanting getting into this and kind of going on forward, this lesson shows you the free stuff, but Simplify 3D is one we recommend for teachers to have more control of their FDMs and get higher quality out of that. So little plug there, just to let you know that there's something that's the non-free version, and we use it all the time in the lab, and we get stellar results out of it. So I'm gonna actually do a quick share real fast for us, and it looks like we can chats here first. Oh, yep, already found the Thingiverse. What we got here on the link here? The Hyperstar filter holder. Awesome.
Yeah, that's something I designed for my telescope, and I shared with everybody.
That's right. We talked about that last time, didn't we?
Yeah.
Excellent. Excellent. And of course, you know, you all can end up with lots of accounts over this, and your students will find new places to go to find these files. You'll be surprised at how prolific students can be with these projects, especially if you actually take the assignment that we use with this task and use it as your own. It works out really, really well, where we just have students say, okay, here's what we need. Some kind of tool that you think is useful, some kind of maybe a piece of jewelry that you'd want to create, and just let them go to town. They upload it, and what's really interesting is they can see the success rate, or I guess you'd say the market's response to it, because the number of downloads that happen off Thingiverse, and that's good feedback for them. And then some people will make comments, so it's like crowdsourcing design in some ways. All right, let's close this. If you'll give me one moment. It's thinking about it. There we go. All right, so we'll do a quick screen share and find the right folder. Number 4. And start sharing. Okay. Can everyone see my list here?
Yep.
Yes.
Okay, yes. Good. All right. So lesson 5, we provide a brief intro to what's going on, and then introduce you to these links and locations. Nothing major to it. You sign up, you get an account. There you go. Have as many as you like. STL Finder is a search engine for finding files that are beyond just one platform. We do see that it has a tendency to want to direct you to paid STL downloads, which sometimes they may be worth it. You know, if someone has a really good model that you don't want to spend 4 or 5 hours doing, it might be worth the $10 to you to just get things going. You will see a couple of things in here that we've listed as optional. We build it into some of our more in-depth classes, but the whole concept of sales and cloud manufacturing is growing in popularity and becoming a thing. It is becoming something that is potentially viable, which we'll talk about the RAMI here in a little bit regarding that as well. Another thing we want to throw on there is the expert roundtable that came from Additive Manufacturing Magazine that we thought was really, really good, and just good information. But then we switch over to slicing. You know, your item number 4 here, the introduction of the slicing, what slicing actually is, for those of you who may not be familiar with it, and what's really going on in the background. Now, for those of you who have CNC background, it's the exact same code. It's just G code. So much in the same way, if you have CNC background, you know, you go from a model, you may have used Mastercam or some other type of software to write the code, and then you put that code on your machine and it executes. It's the exact same thing that's happening here. Simplify or Cura, or the slicer, would be the equivalent of Mastercam. Take the model, write the code, give it settings, give it speeds, etc. There is a tremendous amount of settings in slicing that you can choose from. Obviously, starting off, You just use beginner level, intermediate, where it presets them for you, and then you can go in. But we do cover in this lesson some of the more critical slicing settings that you can play with to actually get the best result. One of the key ones that you will find in terms of the quality of your parts is the layer height. The tighter the layer, the smaller the layer value, the higher quality of prints, and also the higher strength. Your Z-axis weakness goes down with a smaller layer. Or you can think of it this way: the smaller the layer, the higher the Z-axis resistance to break. So that's one crucial thing. But as you can imagine, if you have smaller and smaller layers, what does that do to your overall print time?
Very long.
Makes it longer. Absolutely. So it's this trade-off, but if you've got a ton of printers, you may not care. You can just say, all right, I can fire this up and do this. It looks really, really good. It's strong. You can't even see the layer lines. And that's one of the great things about the Genius. It's a really good printer that can move really fast and hold really, really tight layers. And so you can actually get it down to people can't even see the layer lines associated with the FDM process, which is pretty impressive given its price tag. All right, so we go through all of those things. We talk about support material, and of course, we talk about orientation, your object, and how you set it up on your print. Now, one of the things, if you want to get into a little bit more advanced stuff, is that, let's just say you're making an object, and the normal tendency, let's say you're making a cylinder. The normal tendency is just to set it on the build plate and let it print straight up. The quality looks great. It'll print smooth and quick, but you have that Z-axis weakness. So especially with cylinders where the load may be applied a bunch of different ways, one of the ways you can address this is to take your cylinder and rotate it 45 degrees on the build plate. Negative side, you're going to have support material to hold it in place. Positive side, your Z-axis weakness is 45 degrees out of plane with your object. So no matter which way it's loaded, whether it's tensile or some type of shear force, that Z-axis weakness does not line up with how the force is applied, which is a sacrifice of time and maybe some of the visual quality, but an increase in strength. So something to think about there too. So we also include this just for everyone's reference, and we recommend it too for your all students dealing with all of these G codes. You've got your STL file, your model file, and it goes into the slicer, and then out comes a document that's basically a text document with a code. Well, what do you do with the code? Do you want the students to email it to you to execute on a printer? Is everybody just putting it on a flash drive and plugging it in? And those codes get pretty big sometimes. So as a result, you oftentimes need to store the actual code in a way that's manageable. So that's where we encourage students to really get into cloud storage like Google Docs and links. So what we typically have them do is when they get to this stage, and it's done in this task as well, we have them actually go take their G code, load it onto a cloud drive, and send us the link so that we can actually download the G code into our printer and take off and go. So it's a good experience of cloud storage to go with the actual management of files.
That's if you are using the same printer, right?
Not necessarily. So it depends on your
different
situation.
size. If it is different size printer and you get the G code, then the application of the print will be different.
Well, this is what we do. We have them specify in their name, like say if the assignment calls for them to put it on a Prusa versus a Sidewinder or Genius, what we'll have them do and get used to this for themselves, we'll say, okay, name your file according to the product you want to make, and then maybe do an underscore with the initials of the printer type. So for example, it's going to be a Prusa, we'll just say underscore Prusa. So whoever the technician is taking that file from the cloud drive, they know which printer it goes to. It also encourages them to start learning to do iteration. So it may be a file name of some type. Let's just say it's widget right side, right side widget, right? We would tell them to do right side widget underscore the actual name of the printer. For example, if it was a Genius, we might say GEN underscore 1. so that they know that this is the first variation of that. And then most of the time, people will actually produce more and more and get better with their codes. They want to keep using the same code. So we'll say, all right, _2, _2b, etc. So the management of all these files is a crucial thing. And cloud storage drives, especially since everyone's got free storage on Google or even probably your own learning management system. They can store all that stuff there, but they have to really understand naming conventions and being able to find things. So identifying the printer, identifying the version, the name of the part, of course, is crucial in the process. But yeah, that's how. Yeah, go ahead.
Is there a header in the G code that tells what printer was used?
It depending on the slicer, whether they put that information in at the top, a lot of times it's just generic. I haven't studied a whole lot of the code outputs. You do see a lot of like text information that is semicoloned out at the top that gives some of the basic settings. More than likely it's in there somewhere. We would just prefer them just to say, hey, if you wrote it for the Sidewinder or the Genius, make sure we know it on the actual file name. But you can, most of these G codes are very generic. You can open them up in a text document and see what they're saying.
All right.
That's a good question. And it boils down to management, because at this point in time in the student's progression, you know, you've got 15, 20 students. That's a lot of G codes. And that's a lot of files being printed, especially as you add on more and more printers to your lab. So that management, and especially if it's you who are having to print it for them, or maybe you're assigning 2 or 3 of your really good students to produce, you want to have that naming convention down, because it's really good data. It teaches the ones who are actually running the printers how to manage things, and also how to prepare for the real world of manufacturing, where time is money. You know, are they taking so many different student files and putting them into a batch if it makes good sense for them? Or are they setting them up separately on 4 different printers and they're saying, okay, this one's going to take this long, this one's going to take this long, I'm going to put these 2 together. So it's a really good working experience for those students that you have that may be doing this work professionally. We typically will have a couple of our interns or some of our capstone project students manage this process to really get that time sense and workflow concept down pat. Now, you can actually take a G code and load it back into your slicer, and the slicer basically give you a version of it. So if you want to review a G code to see how well it print before actually printing, you can take their G code, slap it into Cura, and then it's going to give you basically an executed version of that. And there are also G code readers that will show you what's happening in the process too. So it's a really good experience now. And generally speaking, most technicians nowadays don't actually see the G code simply because the slicers are so good. There's no real G code editing that goes into this process. Your settings on your slicer are one thing, but you don't really even need to see the G code anymore to get the job done. And out of curiosity, so questions on that. So, you know, the term G code, does anybody want to ask a little bit of this or that? Maybe even on the topic of a slicer, maybe you've heard about it, maybe not heard about it before. Let's talk about that a little bit. Any questions?
I'm teaching G code right now, so I don't have any questions.
All right. So, and you know, every now and then on the research side, we'll get into there and do a little funky, you know, dwell or something, maybe if we're troubleshooting something. But really, the slicing has become so good, it's just not. It's almost irrelevant. And to actually even know what it's doing. I will go back though. Did anybody have any questions on 1 through 4 that you wanted to ask? Comment on?
Yeah, Eric, I've got a question. Going through 4, wasn't able to download Mesh Mixer. I got a
Really?
I was logged into Autodesk on my educational account, and I got access forbidden.
Okay, all right. So one solution there is this: you don't actually have to log into Autodesk. Mesh Mixer doesn't require any of that. You can just go. Let's see. Hold on a second.
I got a 403 forbidden
All
error.
right, let's see here. So everybody looking up on my screen, let's see if I can get this thing to your tab. I'll just do a search for Mesh Mixer. There we go. And you can route through Autodesk if you want to, but Autodesk just bought Mesh Mixer. They didn't create it. It was already out there. So if you just do a search and just click on Autodesk Mesh Mixer right here, it'll take you right through. Daggone it, that was the first time that's ever happened. Okay.
That's what
Let me
I
try
got.
it this way. Yeah, let me try this one right here.
It may just
Yep.
be a glitch.
That is something brand new. I can go find an executable real fast and put it onto our drive for us directly.
Okay.
Because we keep this around, and this is something new. Let me try something real quick. Hang on. That same thing. All right, let me go find a download point and create a location for us. We can probably use one of the old ones too if we need to. Yeah, I'll work on that for y'all, test one out, and then I'll put just a separate executable location on there to do it. So sorry about that. That's brand new news.
Okay.
Because we just did this install like 2 weeks ago and it was nothing there. Okay. Other questions that you want to ask? Okay. Now you'll notice that we've also included those articles. They're optional, of course, but we always like to throw in a little bit of that with our students just to keep them thinking and see this big picture. In fact, I just got an email last night. You may have already seen the 3D printed houses that happened up in New York. Now there's a group in California that's saying we're going to make a whole subdivision. And they were talking about, and they're going to put little like solar panels on the roof and print these little houses. And they're talking about the cost of these things that are ridiculously low. So that move is on, clearly. And we were on the call. We did some, this week's been a little bit hectic. And I apologize if I haven't got back to some emails, because this week we've actually been presenting to the congressmen and senators because it's that time of year. And they are really intrigued by this concept of automated manufacturing through additive. So it is growing in power and is growing in attention. And obviously the idea of building houses and the materials that go with all this stuff is a hot topic. Surprisingly, one of the things that so depending on your political state, one of our districts is Mitch McConnell. So we were talking to his staffer yesterday or 2 days ago, and the thing they really latched on was the fact that they're starting to use hemp and also the byproducts of beer and bourbon manufacturing, and they're taking those materials and turning them into 3D printable filament. So the idea of using waste to become a product, a material that we can use in manufacturing, is gaining ground. And one of the interesting things is you cannot injection mold with these materials. They just do not flow, but you can 3D print with them all day long. So this whole idea of sustainability is growing quite a bit, and reuse of waste product to become a material to produce with is getting a lot of attention in the political scheme. So we look to see more of that happening, and more than likely we'll be talking about this more over time on our social media, because we have some new samples of some stuff coming down. So it's another thing for you all to play with as you get into it, is just all these exotic materials that you can't manufacture with any other way. Trying those out. Okay, so big picture is always good. always be on the lookout to share those articles with your students, especially I think the house printing right now, since it's such a hot topic. And of course, the biomedical is getting a lot of benefits there. I'm gonna actually send a message to Tyler real quick to see if he can't get us a mesh mixer executable while I'm talking. Other questions that you all want to ask? Okay, so as you see on here, we have the 5th lesson added, and you can obviously, we're kind of wrapping the overall meetings up, but that is there. I'll put one more on there. Won't have a task or anything. It's just there for your information. But it is that final training if you really want to go to that next level with smoothing and surfacing and the cool stuff. Any particular component to this that you've seen or maybe you would have liked to learn more about? That's good information for us to know, hey, I wish we could have hit this a little bit too during this training. So be glad to talk about those real quick.
You mentioned talking about fusion and how to generate, automatically generate parts, but I haven't seen that.
Yep. That's not built into this particular one as the trial run. We didn't want it to be, super overwhelming. What we actually are thinking of is let's get everybody going because this is a multi-year grant. So we're going to get everybody going on the ground floor, equipment installed, etc., and give some time. And then we'll probably swing back around and say, all right, now, if you're ready for the next level, let's do that. So just too much.
All right. So, thank you.
Yeah, just there, but it's coming, and it's amazing. It really is. But we'll be back. We'll swing back around for that.
So that's generative design.
That is generative design.
Okay, yeah. All right.
But it's actually 2 things. So it's actually generative design and it's lattice structure within topology. So you've got one group doing generative, you got another group doing this lattice structure stuff, and they are independent of each other, but they can be merged. But they're both using artificial intelligence to re-optimize. One just does it by thinning everything out and making it look very organic. The other one does it by like cutting chunks out and making it diamond structure or Voronoi structure, all kinds of growth cellular structural shapes.
Hey, Eric.
Yep.
You said we may have more levels. Are you guys thinking about 1 more level, 2 more levels?
What you mean, lessons or actual like cohorts or
Cohorts, like you said.
Yeah. So what we'll probably do, because the objective of the mobile A&P grants is to provide just this experience and then move on beyond the normal. So what we'll probably do later on, possibly next year, is either have another group of cohorts or let all the cohorts access the same thing at once, which would be the next level up. Generally won't come with any equipment, but it'll be more potential training. Our objective now, though, of course, is just get everybody printing as much as possible, get them used to that, and then move up after that point. Any other questions? Okay. Well, let's talk now about what to do with all this. And because you've got the baseline, you've got the equipment, you got students about to come back in. And where do you go with all this? First of all, feel free to utilize any of this material. We will keep this drive active. If you just want to have people reference this drive, that's totally fine with us. We have no problems with that whatsoever. If you want to download the lessons, go right ahead. Again, no problem. They're big and it may take a while, but go right ahead. As we introduce more, you can definitely follow us on the social media as we promote more things that are additive. Use that with your students, especially the articles that we push out, because they are oftentimes inspiring and attention getting for students to see what career pathways may be linked to additive. We will also try to pop out our research. Next week, we do intend on making more comparisons to this idea of a unified manufacturing body nationwide and what that could be. which is one of those things to get people really, really thinking about what they can do with this technology. So use the stuff. Absolutely. As we introduce more, definitely use our YouTube channel, The Additive Guru, because we put more tutorials out on equipment. If you have a problem, specifically like on the Genius side, if it keeps running backwards the other way, then we'll work on figuring out a troubleshooting solution to that, and then put a video out to say, here's the reason, here's the cause, here's how you fix it. So it is there to support you all in your work. So reference that. All right. So the next thing though is the RAMI, the Rapid Response Additive Manufacturing Initiative. And we talked about this before. It is not a requirement for this project. It wasn't written into the mobile AMP, but it is definitely an opportunity if your particular site wants to join in, especially since you have equipment with this that's the same as the rest of the group. Specifically your FDM system, or if you have others. So the RAMI works like this. We have 8 sites across Kentucky that are now set up or being set up as RAMI sites. And so the idea is, in the event of emergency, we basically send a file out to all the sites and say, produce as many of these you can, and either distribute among your own region or send it to your nearest post office with this address, and that's where the product needs to go. That's where the demand is, and we can just ship directly. There's not much to it, honestly, because we will generally write the G codes ourselves, and we will have it all set up for the machines that we know that are in the network. One of the things that we will recommend, though, is you all grow and get more funding through additive. We recommend, if you want to kind of like stay in this network, buy equipment that is, it's actually very, very low cost, but buy equipment that lines with the network. So the the Artillery Geniuses are really good. The Artillery Sidewinders are really good. Even the Ender 3 Pros are really good for this plan because we can just shoot it all out. We are about to promote, not so much promote, but report on one of the 3DQ systems that is fully automated and allows for 24/7 printing hands-free. And it's pretty impressive what it can do, and it's being set up for the Perusas and of course the actual Ender 3. So that's some really cool automation that I think you all as teachers will enjoy, because you simply load up all the files into the printer queue and it just runs them. So it prints, clears the plate, prints, clears the plate, and you can let it run for a week and never have to touch it yourself, which is pretty awesome when you consider the potential of student work that you want to facilitate over time. So be watching for that we release that information on our social media and also our YouTube channel to say it's an option. And it's a really low cost option. It costs about $300 to upgrade one of the Enders, and it becomes an automated machine at that point in time. So if you all, you can talk to your administrators, and if this is something that you all would like to join in on, to be part of, it's very, very simple. We have a network, we have basically a cloud location. We'll add you in as the site. Periodically, what we will do is we will send a test, and just say, here's a situation that popped up. It may be real, it may be what we consider a mock disaster test. Produce. And generally, especially when it's just a mock disaster, we're not going to ask for any kind of specific material. We're just going to say print whatever you have handy, which is typically PLA, and how much, and enter your data. So basically, you would say we would probably send out like a file that says it's going to be 16-hour worth of print. It's going to produce this many parts. All you have to do is take the code, slap it on your printer, hit print, walk away, clear it in 16 hours, and let us know how it did, so that it can run. And it's because we don't want people having to like print one part after the other, after the other, after the other. We want it to be in cycle times, so it would theoretically work really well with a complete skeleton crew. And totally optional for you all, but it's a growing thing, and we're really excited about what it could do, for states in general and our own people. So, questions on that? Did you want to ask?
I found a nylon filament Do you think this Genius printer can handle the nylon?
It can. We've printed in nylon quite a bit. We've printed with TPU quite a bit with the Genius. The catch is you just have to change your settings. You'll have to make it go slower.
And higher temperature, right?
Generally, yes. Yeah. Higher temperature on your build plate, slower speeds. Sometimes we'll have it tell it to add a raft for adhesion.
Mhm.
If your first layer is pretty tight, sometimes not. But yeah, we have the direct drive component of the Genius makes it really, really good for a lot of more flexible materials. So yeah.
Well, nylon is not flexible, but it requires 250 degrees. That's
We
probably,
got her down to about 230, depending on what company you're buying it from. We've actually done nylon at 230
Okay.
without any problems. Yeah. Again,
Yeah.
just slow it a bit more and it heats up fine.
all right, thank you. I'll
Yep.
try it.
Yeah. And you can also try some of the composite blends of nylon that work out really well too.
Well, I found this at the college, so I wanted to try it,
Oh, okay.
but yeah.
Yeah. Good call. Others that y'all want to.
Yeah, Eric, just want to follow up on that. I would be interested in, do you have a knowledge base of using different filaments for FDM, just something out there that we could access, because that 30-second conversation you had there with Jay could be very enlightening if I wanted to start printing with nylon. That's a
Yeah. I'll have to go pull it. And because we keep in one of our lessons, I think one class, and we basically keep updating those documents where we find somebody that has like a good, basically setting printout. I'll just have to figure out where it is right now. And I can share that with the group too. We are kind of working on a better, but what we have as a problem is that like we don't have a lot of web page control within our system. So I can't make like a really good universal page for our group. I keep having to use these documents. So that's been a little bit of a limitation, but I'll see if I can't find you something and put it out there for you.
the shared drive works for me, or seems to be working.
I love them.
Okay.
Others. Yeah.
Well, I have a question. The PLA materials are moisture sensitive, right?
Yes.
How to get them dry? I have so many of them that I partially used, for example, when I needed to change the color. And some became brittle. They break very fast. And some, probably it's the bubbles that caused by the moisture. It's causing deformation in the print. So how do I dry them?
There's several solutions. One, you can just go old school and stick it in an oven and let it dehydrate slowly over time. However, there are some very low cost filament dryers on Amazon. They are just ready. You can just go on there and just say filament dryer and or for 3D printing, and you'll find it. But what we've also seen people do is actually take vegetable dryers and just stick the roll of filament in that, dry it out, and then start printing. If you want to go further than that, you can actually dry it out, then basically a Tupperware container, fill it full of desiccant, and set your filament on a roller in there so it stays in the box most of the time until it comes out for the printer. We don't find that this is actually necessary, because normally if you just dry it out before your production run, you're fine. But some people will do it. Let me see if I can't pull up an example for you real fast.
Yeah, I think we have a printer in the college that has a box where you put the reel in and then you just feed it out of it. I use these tiny packets of demoisturizers.
Mhm.
I put them in, with the filament.
Yeah. That's what I've done for many years, is just keep it in a container with a bunch of those, because every time you order a filament, it comes with a little bag of desiccant anyway. But actually, you can see on the screen, there's a pre-made little package for about 60, 70 bucks. That is a individual roll filament dryer. So you can actually set it and just plug it in right and go. I think we use the vegetable dryer. We use this one ourselves. The electric food dehydrator will also work. So any of these things are actually great little solutions for your filament.
Yeah, that's good to know.
So, and all you have to do to find them is just go to Amazon and just type in, I think filament dryer is all I did. Yep, filament dryer. I even spelled it wrong, and it still got it. So how about that?
Why didn't you give us one with the printer?
You'll have to talk to Ishmael about that one. You know, that's his budget line. You have to see if you can hit him up for some more money. And to be honest, this is a new thing. This is, last year wasn't there. We just bought one of the food dehydrators. And you really won't need this that much for PLA, unless you just leave it sitting for a long period of time. More often than not, we run through them so fast that it doesn't really have time to really absorb. But your nylons, you do want to pre-dry them prior to actually running.
Yeah.
And I'm thinking there's even like, this one's for 50 bucks, and they just keep getting better. And a lot of people just modified them, but they're handy little things for sure. Other questions? Well, while we're talking about filament, that actually brings up another good point too, is because we work with this with our technicians, is that, why are my prints failing? Why is quality not that great? One of the things we do have them test every now and then is filament diameter. So they get out the digital calipers and they take a strand and they just check it. Is it actually 1.75, or is it varying more than the slicer is accounting for? And that will affect your quality of print. Sometimes it'll get thin. Sometimes it'll get too thick. So we have them check the diameter of that. Now, it's not nearly the problem that used to be about 3 or 4 years ago when we were buying some of the lower cost filaments. It works pretty good. For the most part, everyone's got the process dialed in, but it's something to watch for. Another troubleshooting thing that you will see is that if you see your objects start to have like little threads and gaps in the layers of your feature, that's usually a clogged nozzle about to happen. And so you can do like a swap out of the nozzle itself, or you can actually just take another piece of like a little nozzle cleaning kit and clear it out that way. Pretty common though, after you've run, 400 or 500 hours, to need to replace that brass nozzle, which is really easy to do. 3D printer, e-clogger maybe. Let's see if they got it. Nah. There we go. So you can see for like $12, you can get these nozzle cleaning kits that are, super effective. They're basically little thin E-strings off guitar wires, essentially what you're close enough to, that can actually go up from underneath and help clear out the nozzle. Oftentimes, like I said, we just swap out the nozzle, because the brass nozzles on these replacements are like super cheap, which is one of the reasons that we like to use the Genius, the Artilleries, the Ender Pros, is because they're very, very upgradable, and you can actually add in more features as you go along. And so they're basically platforms meant to be improved upon. And for the price tag of getting them for $300, you can set up a really powerful production lab and keep upgrading, which gives students good experience on maintenance when you teach them how to upgrade these printers. It's a win-win all the way around. Because we generally do want students, after they finish their intro class, to go out and buy their own personal printer. Sidewinder, maybe an Ender. Some of them will go out and buy Artillery Genius or Sidewinders or Geniuses, and we would give them information to upgrade. But we want them to produce at home as much as possible. Not necessarily in their bedroom. We do teach them about safety, but we want them to start producing for themselves. So any other questions or concerns about the hardware that you want to ask? Okay. One of the things to keep handy with the resins is always keep your gloves, and keep your little tank of isopropylene alcohol around for the cleaning process. And you can buy you can basically set the parts in the window for faster curing, or you can build a little UV box. Check this out. This will speed up your curing. UV curing, printing. There you go. You can find a lot of these little boxes that are out there. What these guys are actually just doing, they're just taking UV LED lights and putting them in a box and putting a power supply behind them. But it can drastically speed up this one's actually really, really easy. Put this in a box with a little rotating stand, and it will actually cure it really, really fast. So a way to speed up the curing on your resin prints. You are seeing a lot of these ads pop up that I'm doing right now, like the N-cubic photons, the monos. The new mono screens they have on them are faster on the resin. So you all should be seeing increased speed from what was out last year. And you should also be seeing more options for more exotic resins. You're seeing they've got flexible resins out there, engineering grade resins, and the cost for these resins is like a fraction of what they used to be, for liters of fluid. So you can explore a lot of the materials, but really about the materials more so than anything else. So you can explore that with your students as long as you have them, cleaning them well. You can also buy like a little jewelry cleaner that you can put your objects in, fill it full of the alcohol, and it'll basically get that alcohol off of it or get the resin off of it really fast, and then slap it in the low-cost UV box, and you'll have parts. I cannot tell you how much money is being made in the jewelry industry right now and the figurine industry right now with this technology. So any of your students that want to start making money, this is a pathway immediately to get into the jewelry, and even the gaming community is making a killing off of 3D printing, high resolution, resin-based products. It's just a matter of doing it and actually selling it online. So for those students that you have that are entrepreneurial in mindset, this is a great way to get into it. All right, others. I'll stop sharing. Okay. So, and that in mind, George, is there anything that you would like to add or talk about on evaluation as when you're going to release that? Probably want to wait till they've had enough time to do lesson 5. But any comments you want to make?
Not at this time. Yeah, just make sure, you have already said this. Make sure as you are doing your work, keep taking pictures of everything that you are doing, the good and the bad, all the mistakes that you're making. Take pictures of those as well. That would be very helpful. And you can send those to Eric or to me or to both of us.
Yes. We do like mistakes. We love mistakes. And I'm curious on the Genius when it's doing the reverse direction. I want to figure that one out too.
Yeah.
Okay.
Yeah, that's all on my end.
Okay.
For now.
Let's see.
And I will tell you to after the last lesson to expect a survey that is ready for me to send to you and complete that. Add as much additional information at the end as possible as you want to. And also, if you want to just send me an email about anything right now, please go ahead and do so.
On those same lines, when you are filling out your evaluation and it has like the comments and what additional, please make sure to say if you would be interested in going to that next level with generative and in topology in the artificial intelligence design system. Say it, and that way we can add you to the list for the next pass as it comes around, or when we just release it out.
Yes.
So yeah, give us those comments and feedback. All right. Well, at this point in time, there's no questions. Dr. Fadon, would you like to make some comments or throw some extra information in there?
Thank you for being the cohort 1 participants. and we'll be in touch with some follow-up in late this year or next year. We have a trailer specifically designed and fabricated for this project. The intention was to come to your institutions and do the full day training. Seems like we'll just hold it for a while, but late this year and next year, that's gonna be the option. We'll coordinate those activities with, again, Michael, and maybe some beta testing sites. We'll pick some and keep you informed on that. Other than that, we're all set, and George is gonna do the follow-up. We're gonna do the follow-up and start the cohort 2 soon, and get some new participants. The future will be bright. The technology is developing, but we have the materials and resources ready to follow it up. We'll make you all knowledgeable on that. Michael, anything else you wanted to add?
Yeah, I would also say when you complete the survey, it is usually advisable to do it on the computer rather than on a mobile device. Yes, you can do it on your phone, but it may be better, especially if you have lots of stuff to type, to do it on your computer. And it's not going to be long anyway, by the way. It's just 10 minutes or less.
Since it did come up, what we'll do is I'll have Tyler add to your all's platform a list of the common things that you can also add to your lab, like the dehydrator, maybe the other kit, maybe some brass repair parts, just little extra tips for your hardware knowledge. And most of this stuff, we always want it to come from Amazon. So it's cheap, easy to get, and you can get it on demand. And also, more importantly, share it with your students so that as they get into this work, they can go to that quick resource and see what they need to go buy to get into the business themselves. And what we'll also do is maybe like put like a sign-on form or something for any of those of you all who might want to add your site to the RAMI project. We'll just have like information that you can say, you know, hey, we're interested in joining this, and we can add you to the list and start doing a couple of training runs with you just to get production, which again is not a big deal. It's we send you the file, you produce, and you just record. So it's nothing major in that case, but we'll have like a sign-in sheet to say here, you can add yourself to the RAMI as well if you wish to. Okay, in that case, no further questions.
Thank you all, and we'll just stop the recording and wish you the enjoyable weekend. Bye.
Eric, I
Thank
need
you all
to
very
talk to you for a second. Eric, I need to talk to you for a second.
Okay, gotcha. Can do. I'll stay on.
Thank you so much.
Thank you all.